Alright, so same thing. I've got change in position is equal to position final minus position initial, and this change in position by definition is displacement. I've got that same city block. I just can't seem to be able to move out of that city. 10 meters, 10 meters. In this case, I have two people. I have one person represented over here by this green gentleman. I'm going to try to use a green marker to separate him. And then I have another person. I have a person that starts here and then travels to that point. Okay? So he moves from here to here. Okay? So what I want to do is I want to calculate that person's displacement, and I also want to determine his final position. And this should be the kicker. This should be the one that says, hey, look, his position is different than his displacement. Alright, so what I want to do is I want to keep track of his initial position and his final position. I'm going to use it from the point of view of this person, from his origin. So, talking about his initial position, well, put a box here for position initial. His initial position, oh boy, I'm right on the edge. His initial position tends to be 10 meters in the x-hat direction. Okay? That's his initial position. His final position, well, he starts off being 10 meters away in the x direction and then moves in the y direction by 10 meters, positive y direction. Okay? Cool? So 10 meters in the x direction, 10 meters in the y direction. So that is his position. That's his final position. I'm going to go to the other side to do the mathematics on that. So, knowing our mathematics, we're going to end up with position final minus position initial. Position final referred to here, position initial referred to here. So his position final is 10 meters in the x direction plus 10 meters in the y direction. This is position final. Okay? Now, I really hate using P for position. It turns out that P it belongs to another physics term. It belongs to momentum. But I can't seem to be able to avoid using it right now. Okay? Just remember that P will actually refer to something else. If we want, we can use X, O, or R. Okay? Cool? Yeah, let's use R for that. Now, what's his initial position? Well, that's expressed over here, 10 meters in the x-hat direction. So here's his initial. 10 meters x-hat plus 0 meters y-hat equals R initial. Okay? Cool? So I know my change in position is position final minus position initial. So if I were to look at this as a problem, I can just view it like that. I'm going to erase this really quick. So it looks like I've got a mathematical problem. This minus that. Distributing that negative sign, I'm going to end up with negative 10 meters x minus 0 meters y. Okay? And then I'm going to take my x's and my y's, and I'm going to do the addition. So what's 10 meters in the x minus 10 meters in the y? 0. Okay? What's 10 meters in the y minus 0 meters in the y? Cool? That means that his displacement is going to be 10 meters in the y. Looking at it from here to here, how far does he move from the starting position? His starting position is here. He moves 10 meters. And in what direction? Positive y. His displacement in this case, is 10 meters in the y. Bingo! Here's my answer to that problem. What's his displacement? But To answer the questions of all questions, how can I get a problem where I've got a different value for my position as for my displacement? Here is his final position. 10 meters x, 10 meters y. This is my displacement, 10 meters y. Here's my position, 10 meters x hat plus 10 meters y hat. Why do I have a different value for my final position as I did for my displacement? Drum roll, please. Origin. Every problem that I've done up until this point, I've selected the origin to be where the starting position is. In this case, in this problem, I've placed the origin 10 meters 10 meters away in the x direction. So his initial position, he starts off with that 10 meters x. And his final position, he's still 10 meters in the x direction away in the origin, from the origin. So there is a way in which my position and my displacement can be different values. It just is where I select my origin to be. If I select my origin here, I would have gotten the same answer. If I selected my origin some other point than the starting position, then my displacement, or my position, turns out to be a different value than my displacement. Once again, I keep itching my nose on camera because hair's in my way. Cool? Rock on? Happy about it? I hope so. Really important there. That's how I get a different position from my displacement. This is important that you know this. If you want to express it, shorthand, look at the previous video. It's the shorthand expression of it. I left it up here because most people are like, hey, look, there's words in there. That's not mathematics. It's got words in there. Variables are representations of words. Cool? So there you go. There's a way in which I can get position different than my displacement, and it's a demonstration of how I can solve for the displacement of a problem using the mathematical definition of position. Cool.